Here's some practice questions, okay? I'm going to go through these practice questions. They have been given to us by the county as like example EOC questions. The state of Florida has yet to release to anybody a past EOC test so we can see the kind of questions. So a little bit of this is guesswork, but here's the idea. And this particular question that they sent us is asking about an ability of water that we said was called, what do you call that? Surface tension, right? But surface tension is again due to what? It's due to cohesion. It's not really due to adhesion, but those insects' feet sticking to water molecules would qualify as adhesion since they're two different things. So out of these possible answers, this is the best choice. And in a multiple choice question, that's what you're always looking for, is the best answer. Not a possible answer, but the best answer. So that's just a neat thing. See, because if water didn't have surface tension, if water molecules didn't cohere, this guy wouldn't be able to do that, and he's not going to be able to keep that up for very long. But when that big flat flipper hits, the water molecules resist being pushed apart because they're sticking to each other, and if he pushes off fast enough, that lets him do this at least for a little while, walk on water. So, water is an example of whose atoms are held together by which of the following? Well, here again, I'm not crazy about this question because I can make a case for both of these answers. So which one would be right if this was a test, right? So here's a key, and now we're going to practice really specifically reading questions. Water is an example of a molecule. One molecule they describe here whose atoms, that means the atoms in that one molecule, are held together by which of the following? Well, hydrogen bonds are holding together two or more water molecules or other molecules. So now we're left only with covalent bonds. Again, the hydrogens and oxygens are sharing electrons. They're not transferring electrons. They threw this in there just because they needed 4 answers for their question. So here, water is essential to life. Which of the following enables it to move from the roots to the leaves? We described that is due to evaporation, right? But that's not a property of water. That's an event that happens. But the fact that they're stuck to each other when they evaporate, or if they find themselves in a little tube inside a plant, that they can stick to the sides of that tube and move up even without the evaporation, move up a little bit, that is all due to cohesion. It's not about them dissolving anything. It's not about them freezing, right? So A is a good example, as well as B, as well as D, of statements that are true, but they're not answers to this question. This is the only one that's true and an answer to that question. Which property of water allows it to dissolve things so much? Well, out of these choices again, I can make 2 answers work. I can make adhesion work because what is dissolving about? It's about water, right? Sticking to something else hard enough to pull it apart. That sticking to something else is adhesion, right? But what property of water enables it to do so? A better answer is polarity is the property of water that lets it stick. Adhesion is kind of a thing that happens because water has this property of polarity. So that's why you could make a case for this one, but this is the right one. And these two you can't make too much of a case for. This is about sticking together, but it's about water molecules sticking to each other, not something else that it dissolves. This one is the most wrong of the answers. So now we have one that's kind of in the syllabus here. I'm going to add quite a bit to it because really need to at an honors biology level and an IB biology level, especially if this is a pre-IB class that I'm talking to here. This is about pH. You're all familiar with pH. You've had it before. You know a little bit about it, what it's about. You know that we have this number scale that we measure pH that goes from 0 to 14. And you might remember that The smaller the number, the more this substance that we're talking about is described by the word acid, right? Lower number is more acidic. This is such an easy mistake that you're going to make it for the rest of your educational life. When you think of something that's really acidic, you tend to make the mistake that that must have a high pH, high acidity, high pH. But acidity is just one end of this scale. The other end, where the high numbers are, is the other side of the coin. The basic numbers are higher, the acidic numbers are lower, so don't forget that. Something with a pH of 3 is more acidic than something with a pH of 5. A higher number means less acidic. Okay, so what is pH all about, though? And why is it crucial to life? Well, again, it has to do with chemistry. We're going to get to that more specifically in a second. But here's what this is all about. This is, again, about tug-of-wars and the electrostatic attraction, the force of electrostatic attraction between the negative part of an oxygen and the positive, the negative part of a water molecule, that's the oxygen part, and a positive, that's hydrogen. Sometimes, as this shows, that hydrogen bond that's holding them together and the fact that these are being collided into by lots of other things, right, will actually cause this oxygen molecule, this water molecule therefore, to pull off this hydrogen, but only the proton part. It leaves its electron behind. So now this little piece of a water molecule has an extra electron and therefore is negatively charged. Therefore, it qualifies as an ion. These are the kind of ions we call polyatomic. They're not just one atom like a chlorine or a sodium. They're made of at least two, if not more, atoms, polyatomic, and they have a charge. Since this one grabbed a positive proton without the negative electron, it's got an overall charge of +1. The names for these two kind of ions are hydroxide and hydronium. And the man, and I forget his name, the man who cooked up the pH scale decided to focus on the hydroniums in a solution and the measure of hydroniums. And in fact, that's what the H in pH stands for, is hydronium. The P stands for power. And I'm going to explain it to you. This goes well beyond what you need to know, but not in chemistry next year. You're going to need to know this. So I'm going to give you no extra charge here. Okay? So if you had a quantity of water that we call a mole, some of you have had moles before, what the concept is, but it's kind of like gallon. It's like a quantity. It's a particular quantity that was made up by chemists to talk about chemicals, right? So just think of it as a quantity, right? If you had a glass in your hand and in that glass there was a mole of water, what would the hydronium ion concentration be? How many of the water molecules at any one instant in time would be pulled apart by this tugging and pulling and result in a hydronium concentration? How many moles of hydroniums would you have? Well, it turns out that you'd have that many moles. That's 1/1,000,000th of a mole. For every million waters in there, there would be one hydronium, to put it another way. That's what concentration means. Out of all the molecules you have in this stuff, how many of them are this, how many of them are that, right? What is this in scientific notation? It's 10 to the -7th. This is what this guy decided to make the pH scale about. He said the pH of a solution is equal to the negative exponent of the hydronium ion concentration. What's -7? 7. That's why if in this glass you had 1 mole of pure water, nothing but water, its pH is 7. That's where the 7 comes from, right? What happens if I make more hydroniums? What happens if instead of 1/10 millionth or 1 millionth, or that might be 10 millionth, I don't know my decimals this far, right? What if I had this much, right? What if the decimal point's over here? Well, 0.00001 is a lot bigger number than 0.0000001, right? In fact, how much bigger is it? It's 100 times bigger. 2 decimal places is 100 times. What is 0.00001? It's 10 to the minus 5. So what would the negative exponent be of this? Negative 5 is 5. Something with a pH of 5, a solution with a pH of 5, has 100 times more hydronium ions than something with a pH of 7. Every movement of 1 on the pH scale is 10 times more because those are exponent numbers. So if that makes sense, good for you. If it doesn't make sense, don't worry about it too much, but that's where the numbers come from. I just wanted to let you know where they came from. It's all based on the hydronium ion concentration, and that's why this system causes the acidic solutions to have a lower pH, because a 10 raised to a lower number is more than a 10 raised to a higher number. Enough about that. Here we go. Why is that important for life? Once again, it's chemistry, right? So if you have a solution that has a whole bunch of these hydroniums, right, these H3O pluses, a whole bunch of these, you have a whole bunch of positive charges pulling and tugging on any kind of negative charges in there. And especially if the molecule you're talking about is a big protein, and this tugging and pulling of all these hydroniums tugs and pulls this and tears it apart, or just even gives it a different shape, not even tearing it apart, this molecule doesn't work like it used to. And what's the work mean? It's the chemistry of life. Now, this would also be true if this solution had a whole bunch of hydroxides. If it was a base, a strong base, the tugging and pulling of those negative hydroxides might tug and pull this apart. So that is why the not only temperature of life's chemistry must be kind of within a narrow range of moderate temperatures, but so must the pH. It must be in a moderate range of pHs, which is usually, again, somewhere around 7. So this is what I said. Again, I anticipated this slide being up there before, so I explained this slide right here. Why can this disrupt the chemistry of life? It's a tug of war. It's the electrostatic attraction of positives and negatives. What are the positives and negatives in this case? Molecules needed for life and hydroniums and hydroxides. All of them are charged. Tug and pull too much, you disrupt those molecules necessary for life. Here's the question, right? They love kind of questions on your EOC test that are based on data and or graphs. And so here we have a graph with your question. Which statement best? When they emphasize the word best, they're kind of suggesting to you that some of these might be okay. We want you to pick out the best one, right? Summarizes the information in a graph. Well, what's the information in a graph? Here's how I would approach graphs if I was you. The first thing to look at is the labels on the axis. What do these numbers mean? Oh, they're the number of living cells. What do these numbers mean? Well, this is pH, right? So where is the highest number of living cells? Ooh, that's at a pretty low pH. These cells like acidity. That's what this graph says to me. When the pH gets higher, even if it's still quite acidic, pH of 3 is quite acidic, there are less living cells than when it was around 1. So that's what this says to me. Now, which one of these is closest to that conclusion that I came to? The cells survive best under acidic conditions. Boom, that's good. But they wanted the best answer. Maybe one of these others is better, so I better read them all, even though this one I don't have much arguments about. The cells survive best under basic conditions. That's definitely not what this graph shows. They would survive better in still water. Distilled water would have a pH of 7. I would suggest that even though this doesn't have 7 on it, the way this is going means that's probably not right, so it's certainly not a great answer compared to number A still. The survival of these cells does not affect pH. Well, it's actually pH, that's the variable that's affecting this. So while we're at it, we'll practice this. I think we probably said this already, right? Which one of these is the dependent variable? It's this one on the y-axis, right? Why do we call it dependent? Because it depends on this one. How many cells are alive depends on the pH, not vice versa. The pH doesn't depend on how many cells are alive. The pH is all about hydroniums and hydroxides. So, drink up and stay healthy. Hope you enjoyed that one.